Here we go with the second part of chapter 9. We call this 9.2 day 1, day 2, day 3, day 4. This is going to be the first day. Going to have to do with angles, angle measures, and degrees. Have your note packet ready to go. Here we go. We start off with a little review from what we've done. What we've done to this point. If I was solving this triangle, the first thing I would do is find this value c by using the Pythagorean theorem. 13.4 squared plus 16 squared is going to be c squared. Square those, add it together, you get 435.56 is c squared. Square root that guy, I get like 20.9. This would be an estimate. We're rounding, right? I think they've got a rounded value there as well. If I was going to then find angle A, because now I've got big A is, I don't know, big B is, I don't know, big C is 90. Little a is across from big A, 16. Little b, 13.4. Little c is now 20.9. Again, we want to do this with SOHCAHTOA. I would do the sine of, oh no, I wouldn't do sine. I would, because that was rounded. I would use the given values. I would do tangent, tangent of A equals 16 over 13.4, which means A is the inverse tangent of 16 over 13.4. So inverse tangent of 16 divided by 13.4. I'd get A is approximately, I got 50.05. Let's call it, I don't know, 50. You want to go 0.1? Sure can. 50.1. 50.1. And then B will be 90 minus 50.1, 39.9. Also, you got to draw a picture here. Words. David needs a ramp to rise to a height of 3 feet. Here's my 3 feet at an angle of 15 degrees. So I got come out here. Not drawn very well. 15 degrees. Right angle. Find the length of the ramp. This is going to be the length of the ramp. You can call it R. Be the sine of 15 degrees equals 3 over R. Over 1 crisscross applesauce, R3 divided by sine 15. Use your calculator. Make sure your calculator is in degrees. I get about 11.6. 11.6 what? Looks like feet. 11.6 feet. That's for the length of the ramp. Okay, we're going to talk about circles and degrees. When we talk about degrees of a circle, all the way around a circle. Whoa, what happened here? Whoa, let's erase that. There we go. All the way around a circle is 360 degrees. We usually talk about angles when we're just talking about regular angles. We're talking about 0 to 180. Now we're okay talking about all the way around a circle is 360. Standard form, which we will talk about, starts out to the right, and then we go this direction. 90, 180, 270, 360 is all the way around. This is not new material. We've used degrees before. When we're talking about standard position, if the measure of an angle is positive, then we're going, this is standard position, and this is the initial side. Positive angles rotate counterclockwise. This is called the terminal side. Terminal side is this side. Now if we have a negative angle, we rotate clockwise. So we got counterclockwise for positive. Negative is clockwise. We're coming down this direction. And I've got a negative 135. This is the initial side. This is the terminal side. Terminal is where we stop. Terminate. Draw an angle that is 50 degrees in standard position. We start out to the right. We turn up. We'll estimate 50 degrees. Label it. Remember, this is quadrant 1. We often do these with, this is quadrant 2, this is quadrant 3, this is quadrant 4. 50-degree angle is going to be from in quadrant 1, and we go from there. 150 coming over here. 150 ends about there. This is our 150. Initial side is out to 0. Here's my 90. Here's my 180. Going to be very important coming up here in the next couple of lessons that we understand that this little angle here formed is then 30. That's going to be very important. This ends in quadrant 2. That will be important down the road as well. Negative, watch out for negative. We always start out to the right, and now negative is going to go this direction. This would be negative 300. There's my terminal side. I land in quadrant 1 because I went backwards 300 degrees. And then this little angle that's left over here is actually 60 degrees because the whole thing would have to make 360, so that's going to be important down the road. But more on that later. Negative 45, going to land down here in quadrant 4. 45 going to be important. Coming back to our 45, 45, 90s. There's negative 45, starts out to the right, goes down. We land in quadrant 4. 900-meter dive, so you need to think about 900. So we start over here. So we're just going to go around and around and around. So I go 90, 180, 270, 360, 450, 540, 630, 720, 810, and we land. So if you take a look here, we're actually going once, twice, 2.5. So if you're diving 900 degrees, you're really rotating 2.5 times. We're actually ending on the 180-degree axis over there. Snowboarding, we're going to do a 600, man. And we're going to go 360, 450, 540. 600 is going to actually be right about down here. I guess maybe I went a little bit too far, but I'm landing in quadrant 3. Went around once, 1.5, a little more than 1.5, and I'm probably going to land a little bit cockeyed, which means I'm probably falling down. Nope, I'm a good snowboarder. I'm going to land it 600 degrees. Co-terminal, to terminate in the same spot, sharing the same terminal side, to end in the same spot. Look at these 3 angles that we have here. We have a 45-degree angle right there. And then I have a 315, which comes all the way around, stops in the same spot. 405 goes 360 and up 45. We're terminating all in the same spot on this guy right here. So that means a 45 and a negative 315 and a 405, all in degrees, all are coterminal. They terminate or end in the same spot. All of them have to be starting with this initial side and ending in the same spot. So if we're talking about a 65-degree angle, we're going up here to 65. Draw a 65-degree angle in standard position. Name one positive and one negative. Now, you live in Sartell, or you've driven in Sartell, you've been around the roundabouts. Sometimes you go around the roundabout more than one time. That's what coterminal is. Because all I really need to do, if I want to know, hey, what's a coterminal? I can add 360. I go around the circle another time, and I end up at 425 degrees. So if I started here and went around 360, plus another 65. Look at that. I land in the same spot. 425 coterminal. And then the other thing you can do is you can subtract 365. Well, excuse me, 360. 65 minus 365, negative 295. So if I had gone backwards, let me grab a different color here so we can see what the heck we're doing. I could go this way, 295. So negative 295 crashes me in the same spot. So those are coterminal. So you can add 360 and subtract 360. So, or you could add 360 more than one. You can go around the roundabout a bunch of times. So eventually the police might get upset about it, but doesn't mean you can't go around the circle again. and I get 665 would be coterminal. And then I take my 305 minus 365, and I get negative 60. I guess I didn't draw that one, did I? Here's 305, and then this should be 360. This should be 55. Almost made my first mistake of the day. Not bad. Good recovery. Negative 55 is the same as positive 305 is the same as 665. The 665 just takes you around the old loop-de-loop another time there. So we can go, hey, 360, and then we go again, and we end up there, 665. And we keep going, and again, we can add 360 and get 345. We can subtract 360 and get negative 375, and we're good. And we can, I got to get a positive and a negative. I'm going to have to subtract 360 and get 105, and then I'm going to have to subtract 360 again and get what? Negative 255? Something like that? Or is it? Yeah, is that right? I better check my math there. 105 minus 360. Oh my gosh. 105 minus 360. Oh, I got it. Even when I think I'm wrong, I'm right. Okay. All coterminal angles, we just showed that. We can say, we can take any angle theta. So this is some angle. It's just taking the place of an angle. And we can add on 360 degrees times n. N is going to be an integer, so it can be 360 times 1, 360 times 2, 360 times 3. Just means you're going around the circle again. N can also be an integer, can also be negative. So negative 1, 360 times negative 1 would be minus 360. 360 times negative 2. So you can find all. Please note that this plus or minus 360 or 360n, if it's radians, it's just 2 pi, plus or minus 2 pi. What is a revolution? Talking about a revolution wherever you go. A revolution is one trip around a circle. One turn of a wheel. Circumference, 2 pi r. Circumference, the distance around a circle. Also one trip around a circle. Right? So 360 degrees, also one trip around a circle. So a revolution, a circumference, 360 degrees, all going to be very important. Jordan loved the half pipe. Jordan loves the half pipe. Ugh, grammar. And wants to try the Ollie Fakey 2 Air Double McTwist 1280. All I see is 1280. How many revolutions will he make to complete the 1280? 1280 degrees. I'm just going to divide it by 360. Right? Because if I want to go, oh wait, I think we want to do dimensional analysis. Sorry, let me start over. Let's pretend like that didn't happen. Starting over, 1260, 1260 degrees. I want to get rid of degrees. I'm going to go to is one revolution. Oh, there we go. 1280, excuse me, 1280. So I can do 1280 divided by 360. And that will tell me I went 3.5 repeating, which is 32 ninths. That's how many revolutions we did. 32 ninths would be about, 3 and 5 ninths revolutions. The Pop-Tart is 540 and the Lando Roll is 1440. Okay. Are either of these coterminal? I'll take your 1440 and start subtracting 360. 1440 minus 360 is going to give you 1080. 1080 minus 360 is going to give you 720. 720 minus 360 is going to give you 360. And so really 540 is not coterminal with that. Are any of them coterminal with the double McTwist? 540, I can go plus 360 is 900. 900 plus 360 is 1260. So nope. Nope. Doesn't work. Mr. Brust rides his unicycle over a line of fresh paint. He continues to ride in a straight line, leaving marks that are 6.5 feet apart. That means when we go here, when we go all the way around and come back there, we leave a mark, and so on and so forth. That means that this 6.5 has to be the circumference, equals 6.5 feet. What is the radius? 2 pi r equals 6.5. Very important that you understand that when you take your calculator and you divide by 2 pi, you got to put this in parentheses. So 6.5 divided by parentheses 2 pi. If you don't put it in parentheses, you don't get the right answer. That means the radius is 1.0345 feet. Okay? Please make sure if you're going to divide by 2 pi in one step, you take a look at what the, or you have to have it in parentheses, or it doesn't work. I think that's it. So next you can roll on to your 9.2 day 1 worksheet. Go get them.